Okay, so attempt number 63 on making a thermocline. Not as easy as making a halocline. So here I've got water that I've cooled down a bit in the fridge, and add a bit of pink food colouring to this, and I'm going to help that pink food colouring to mix, because the cool water, the water particles in the cool water, they're not moving around very much. So food dye needs a little bit of help to mix up, and hopefully that food dye is well mixed now. Whereas with the hot water, this is water that I've heated up. Imagine that summer, here's a deeper cold water, and the sun is beating down on the surface water. Surface water is absorbing the sun's energy. Particles in that surface water are moving around much more quickly, much more energy, and the surface water expands and becomes less dense. And with the hot water, the food colouring mixes a lot more quickly. Now, this very hot water, or warm, it is very hot. I get the funny feeling it's going to be too hot. This hot water is less dense, so it should float on top of the cooler water. Ow, just put it on my finger. And it is hot. I think this point is a point at which I wish that I still have some blue food colouring left, because I think the blue food colouring, you see a much clearer thermocline than if I use pink and yellow. Oh, we go all the way up to the top. One of the beautiful pretty effects that we have with water, different density, is this shimmering effect that you get. It's been a little bit mixing, but hopefully what you can see here is a fairly clear thermocline there. Cold pink water at the bottom, yellowy orange hotter water at the top, and here is where we have the change in temperature. And because the hot water is less dense and tends to float, it's going to resist mixing with the colder, denser water that's down below. And around here in the middle, if I move it a little bit, you should be able to see that thermocline moving about here, about there. Now, what happens when the summer's over, we start to get these winter storms? Get lots of wind and waves on the surface. So I'm going to try and set up a mixing current here. We've got waves on the surface, wind on the surface, we get agitation. You might be able to see mixing there. And here, this agitation at the surface is causing currents that are mixing, and gradually the thermocline is getting lower because the two waters are starting to mix, which is what would happen when we get our storms in the autumn and the winter after the summer. And now the thermocline is down here, till gradually all the water in the water column will have mixed. And that, I think, is about as good as I'm going to get. So that's my last thermocline video.